All right, welcome to video number 3 in this series of checking out how radiator pitch affects, I guess, the performance of a radiator, right? And also it turns out it's a demonstration of how traps work from our last video. And I'm just starting up the boiler again. Here's the condensate from the last video. It's just that much. You know, that video ran, I mean, I didn't, like, not the video, but the session of the boiler operating, it was close to an hour. And that's all the condensate. But it is a small radiator, only about 20 EDR. So, like I said, I would just pour this condensate back into the boiler when I was done, so we can see how much. And so this is just like the condensate from my dehumidifier that I use for makeup water now. If you've seen my other video, which I'll put up one of those card things pointing to it, but that's just distilled water back into the boiler. And for anyone who's concerned about the quality of distilled water in a boiler, just remember, I just did by hand exactly what happens the entire time that you are running your boiler. When your boiler is making steam, this condensate is it's running back down through here. It's not running yet because I'm not making steam yet, but it's running here into the wet return, all distilled water. So there's really, I can't imagine any harm from putting distilled water in your boiler as makeup water. I've been doing it for about a full season now, and less dissolved oxygen. Certainly less chlorine. Chlorine can't be good for iron, right? So there you go. So let's see. So we're starting up the boiler. I'm gonna pause the video again here while things get heated up. It takes about probably about a half hour for this radiator to get fully steamed up and going. And again, I've got a couple radiators turned off upstairs to force more steam into this radiator to keep things moving quick. But I'll just edit out any boring parts. Well, I'll edit out some of the boring parts and leave some of the others. But the one thing I still have to do, I'm about to do, is to change the pitch. I'm going to put a 2x4. I'm going to put a 2x4 under this side, and then I'll show you what the pitch is like. So just 1 second. Okay, so here's my 2x4, piece of scrap. Let me try and lift this. It's pretty heavy. There we go. I kicked it underneath there, so 2x4 under there. Let's see. There we are. So we're tipped in the wrong direction now. We're tipped back toward the supply, which is over here, and we can see there's level, and we can see the distance there that we're off level when I let it go back down, and tipped in the wrong direction now. So let's see if something interesting happens. This radiator's cooled off now. It's probably 65 degrees in the basement here, I guess. And this is basically room temperature. I can feel maybe a little tiny bit of warmth, but this is all cold. So we'll see how this goes, and we'll see if we get any banging I mean, I just tipped the radiator up, so it's gonna have some water here. I guess I should have, I could have tipped it up toward the end of the last cycle, but it was hot. Because that way I could see if there's any, because if it's tipped like this all the time when it's running, it would have more condensate in it that would be cold. So maybe I'll take this plug out and I'll pour some condensate into the radiator really quick. So I'll do that, and then I'll come back once this thing starts steaming up. Okay, so I'm just pouring some water into the radiator to make sure that it's basically in the same state it would be at the end of at the end of the previous call for heat. So it's dramatically tipped. Hard to tell from this angle, but you saw the level. It's dramatically tipped this way toward the supply side, and it's at the point where there's just I poured excess water in it and the water drained out of the trap, and so it's like it would be at the end of a call for heat, right? So again, I'll pause the video and come back when it starts filling with steam. All right, I've replaced the plug on the radiator. The vent port is still closed like it was last time. The steam supply coming through this CSST pipe, the steam is progressing down. It's about this far right now. And again, this pipe looks like it's, from that angle, it looks like it's going uphill. But now here you can see from eye level, it's not going uphill, right? So the steam can make its way down that pipe. Condensate will also be flowing down that pipe, which is fine in this two pipe arrangement. And the fact that steam is coming down the pipe at all tells us that even though I've got this radiator pitched pretty severely in the wrong direction, again, this is it's a top input situation here with this radiator. So I can already tell you, it doesn't matter how much I tip it. At the bottom here, it could be totally flooded. The steam is going to come across the top. I think in a steam-only radiator where it has to be fed from the bottom because there's no passageway at the top, it could be, if it was tipped the wrong direction far enough, obviously it's going to flood. It's going to flood the bottom, or I guess the condensate might run back down the supply side. That could potentially happen. The way I have it now, though, feeding at the top, this could all be, if this is level, this could all be underwater and it would be fine. So again, I do want to test this scenario with a single pipe arrangement, which I'm pretty sure I'll be able to do. I think I just have to raise this radiator higher, so I can. Still don't know exactly how I'm going to do it, but I've got to be able to feed it down here, and also let the condensate run out down here. So I'll figure it out one way or the other. I don't know what it's going to involve, but I think if I put the radiator up higher, I could be able to do it. I'll figure it out, whatever. But for now, this is a two-pipe scenario with the radiator severely backward pitched and we'll see how things go once it fills with steam. Okay, steam's coming into the sections now. This is just like the last video. It'll start to fill the sections, so I'm going to edit out quite a bit more of it. I don't need to follow along because we saw it in the last video. So I'll be back. Okay, it's only been a little over a minute since I cut away, and the condensate's already coming out. I think before, in the previous edition, the previous video, I think I didn't pre-fill the radiator like I did in this one, so a lot of condensate had to fill up the radiator and then fill up all of the, I don't know, I guess it fills up part of the piping there, had to fill it up. I assume though that was all empty at the start of this run, so I think it was just the part along the bottom that had to get filled up last time. But this time the whole radiator's not even hot yet, and the trap's already letting condensate out. So that's cool. I think this is going to be an even more boring video than usual because I think it's just going to work and there's not going to be anything crazy. There's been no banging yet, but you know, the steam, zoom out here. The steam's filling from the top in this case. The bottom, there's no heat here yet. Just a little up here though. The fifth section is starting to get warm. These ones are all steam hot at the top. So we can imagine what's going to happen. It's going to be similar to last time. The steam will go pretty much all the way across the top, and then the last 2 or 3 sections will start to see the heat as the steam starts to come down here first, and then all the rest will become heated and filled with steam, and the trap will let all the condensate and water come out. So I'll pause it again and come back when there's more steam in this thing. Okay, we're a few more minutes in, maybe 5 more minutes in from the last time I paused it, and I did go upstairs and got my my IR camera, and I got a shot of where we are at currently with the radiator. And I'm going to I'll put the shot up while I'm speaking right now. But where we're at is we're fully hot across the top, and then it's funny, it's not the last section, or I think even the last 2 sections where the steam is starting to come down. It just, for whatever reason, started coming down, I think in the 3rd and 4th section. Maybe it was 3rd and 4th from the end, I mean to say. So it was right around here where the steam started to dip down. And it's somewhat, it's not random, but it seems random to us when we watch it. I don't know why it chose to start coming down right here as opposed to like the very last one, but for whatever reason, right here is where the steam found it easier to start traveling down. And I think once it starts doing that, once it starts going down a path, I think it's even easier for it to continue down that path, because the steam that comes down, it condenses, and that creates a local area of vacuum. So, if a little bit more steam starts condensing here for whatever reason, then that's going to create a local vacuum that's going to tend to pull more steam in this area versus all the other areas, apparently, is what we saw on the IR camera. And I'll let it run for a few more minutes and grab another grab another shot with the IR camera. But you can see we're getting what we got last time, which in fact this time it's even more so sort of pulsing more obviously, right? Like there, it released, then it closes, then it releases more, then it closes again. So it's definitely doing this cycle faster this time than it did last time. I don't know the reason for that, if it has to do with with the angle or what, but as far as how it's behaving, it's just fine. And I really like how these things work. It really makes me wish I had a 2-pipe system now, because this is pretty cool. I mean, certainly it's a lot more stuff to mess around with a 2-pipe system. You know, you get to go around and check your traps and maintain them and all that stuff. Now, Jamie on the Heating Help forum, he'll tell you, he's had his traps are decades old, I believe, many decades, and they're original. I think they're original to his system, which is definitely a 2-pipe system. And he told me he's got all Hoffman. He said Hoffman 7 and 8. Now, when I looked at the Hoffman part numbers, I saw Hoffman 8, which is a 3/4 inch fitting on the trap. I didn't see a 7, so maybe it's 17, or maybe they changed the numbers over the years, because currently this one is this 1/2 inch one is a 17C, and it happens to be a swivel type, a straight swivel, so it doesn't exit out the bottom. It exits out the side. So in the case where you need the outlet pipe to continue horizontally for a while, you would use this trap. I just bought it because it was one of the cheaper ones I found on eBay, and I didn't care what the orientation of it was, because I knew I was just going to be messing around with it. But he'll tell you, if the traps are cared for, they'll just keep going and keep going. And people warn about too high pressure on the traps, but these come rated from Hoffman, I think, up to 15 psi, and some of them are up to 25 psi, but those might be larger ones that are like F&T traps. These Radiator ones, though, I'm pretty sure I'll check it and I'll put up a screenshot or something into this video, but I believe they're definitely they're supposed to be okay to 15 psi. Now maybe they don't live as long if they're at those high pressures, and as we all know, there's no reason for them to be running at those pressures. People often say you just need a few ounces, but in my experience, you need an ounce maximum. My whole system runs all day long. It doesn't go higher. Right now, I don't let it go any higher than 5 inches of water column, which that is like a couple ounces. But when it's normally doing a call for heat, it stays at 1 to 1.5 inches of water column the entire time. And a few other people are set up that way as well. So it just doesn't take much pressure to push the steam around. Steam is very light. It's not dense. You can shove it around with just a tiny amount of pressure. And there you go. So I'm going to go grab the IR camera now and see where we're at with the heat for this radiator. Okay, I left the camera going so I can narrate this. We can see where the hottest part is. Now the hottest part is moving more toward the left. That's pretty wild. The steam, it just goes where it goes. It's like a river. A river goes where it wants to go. Runoff water runoff down your driveway. It's the same. It's the same. It just goes where it's easiest for it to go. But it is interesting. We can see. I can't point really. Maybe I can on this camera. Let's see if I can get my. Oh yeah, here we go. There's my finger. So we can see down here. This is where the cold condensate is at the bottom with the reverse slope of this radiator, right? You can see the angle there. This thing over on the left, this is my, right here, this is my my drip at the end of the main. So there's the end of the main. There's the CSST wrapping around. Everything's cool there. And it's yeah, I mean it's pretty cool. It's feeding into the radiator. You can see how the heat pattern it moves around even while I'm talking right now. You can see it moves around. The steam, it's just going back and forth. Where's my hand? Whoops. There it is. It just keeps like going back and forth. Sometimes it's more down here. Sometimes it's more over here. And then if we look at the trap, this is cool. You can see the trap is hot. It's not steam hot. Like steam hot is this white color up here. Well, it was white. It's showing 201 degrees right now on that white part there, and then this part is much cooler. You see 144 in the fitting there that leads to the trap, and then let's see if I can find out what the trap is. Well, 132 at the exit. Oh, and you can see the water drip. That's pretty good. You can see the warm water. 150. I can't read it. 150, I think. I wonder if there's like steam escaping out. It looks pretty warm. Let's see if I can feel it. No, I don't feel anything really. I think it's just the interior of the trap is hotter than the exterior, which obviously is radiating heat. But that's a pretty good shot right there. You can see the trap is cooler at the outlet. That's pretty sweet. And apparently you can use an IR camera to determine if a trap is failing. But what you would do is you'd see the pipe, the outlet pipe, it would be vertical in most cases, right? It'd be here. And if the pipe below it looks like my finger looks, cool, then you're good. If you're looking at a trap and you see steam heat underneath it, you know that either that trap is failing or potentially some other trap has failed and the steam has come up from some other trap in the system. But if you watched the traps from startup, you would see where the steam's escaping. And let's see here. I'm going to put my hand up here. I think some steam is coming. I think a little bit of steam is escaping the trap, which it was doing it last time. It's not a whole lot. Every so often I get a hint of, I can see the cloud, a wispy cloud of condensed steam coming out of it, and I can kind of smell it. But it's not coming out heavily or anything, and that makes sense. In the normal system, if it would have the pipe coming off here, a little bit of steam would escape into the pipe and it would immediately condense out, and it wouldn't make it'd warm the pipe slightly, but there's not enough steam escaping from here to heat up a pipe, I don't think. So okay, I'll take another look at the whole radiator. I got to back up to do this. You know, I think before when I said that the steam wasn't getting to the end, it might have been my camera in the way. See how my camera's in the way? I'm not certain, but at any rate, you can see the steam is filling up the radiator, except for this angle part, right where my finger is. That's where the cold condensate is down there, from the backward angle of the radiator. So two pipe doesn't care if your radiators are tilted backwards. Don't sweat it. That's the lesson from this video. I'm going to stop recording on the IR here. That's the lesson from this video, is if you have a two-pipe system, who cares if your radiators are the wrong direction? It just doesn't seem to matter unless I'm overlooking something. You know, yell at me in the comments if I'm missing something here, but what I'm seeing is the trap is doing what it's supposed to be doing. It lets the condensate out. It holds back the steam almost completely, and the radiator gets hot, and there's been no, not one sound, not one peep out of this radiator, even though it had cold condensate in the bottom of it. But the steam isn't moving. It's not coming across that cold water in any kind of violent way, or there's no conflict there. The steam is slowly making its way down from the top. It's coming down and it's heating as it goes, so it heats the water up and it didn't make any bang. It'll be really interesting to see if I can get this thing to bang at all, even like with a one pipe system. It'll be really interesting to see what happens there. But again, I still got to figure out how to get one pipe steam into this thing down here in my basement and somehow deal with the condensate. So we'll see. And at this time, we're 25 minutes in or so from pretty much when I started running this continuous video, and we're just at 0.5 psi. Now, I did open up one of my radiators upstairs because my wife was complaining that it was getting chilly up there. So I opened up one of the radiators and left the big kitchen one closed. So building up pressure is happening not quite as fast as it did in the last video. Oh, and I remember one more thing. Do you remember when I ended the last video, the boiler stopped, and I was like, why did the boiler stop? That's weird. Like, it hasn't met the thermostat. I've cranked up the thermostat. I didn't really get it. Did anyone else figure out what happened? I figured it out when I was on my way back down here for this video. What happened is the pressure troll kicked in, which it's been so long. It's been 2 years, I think, since my pressure troll has activated, because I have this low pressure switch that activates way before the pressure troll is even close. So it's been so long since the pressure troll activated, I forgot that it was even a control on my system. But I'm kind of glad to give it a chance to test it today, because you obviously want to have a good pressure troll that works, and mine did work. I'm pretty sure that's what shut off the boiler, because when I went back upstairs, the thermostat wasn't satisfied yet, and the cycle guard hadn't kicked in. So the only thing left that could have stopped the boiler was the pressure troll. And then if you recall from the last video, the boiler kicked back in again shortly while I was still closing out the video, it started back up again and really confused me, but it was the pressure control the whole time. So, okay, that's it for this video. Again, the summary for this video is the angle of your two-pipe radiator. It doesn't matter. Like, don't sweat it. Even if your floor has settled and it's tipping the wrong way. I mean, maybe if you were feeding from the bottom, maybe you'd want to be sure it was at least level, because you wouldn't want the condensate drop, running backwards down into the supply line of a two-pipe system. It would probably, I don't know if it would make some gurgling sounds or what. It might bang, I don't know. But if it's being fed from the top, like my setup here, this thing could run at who knows what angle. So there you go. Now, no one's going to believe me when I tell them this on heatinghelp.com. They will fight it tooth and nail, and then for the next several decades, they'll still be telling people to make sure their radiators are pitched the right way. And again, with the one-pipe system, we'll see how that goes. But I know at least a couple people on the forum are like, yeah, the pitch doesn't matter. Like Charlie from Western Mass, I believe he said that radiator pitch is a big red herring, and this would agree with you, Charlie. So that's it for this video. I'll try to figure out how to get one pipe set up, and that's it. Later.